Welcome back to the channel, and I thought I'd start off 2022 with the cheapest insulation tester that was available to me. Now these two units here are based upon the Vici 60B Plus. There is actually a cheaper insulation tester out there, that's the BM500A, but I could only get that from China. I couldn't find a stockist within the UK for that one. So I may get that one in the future, but at this moment in time I'm going to stick with this Vici 60B Plus model. Two versions that sit in front of you from different manufacturers, one from Vici, the other one from WinsPEAK, because not only is this one of the cheapest insulation testers out there, it's also one of the most cloned insulation testers out there. There's a myriad of different manufacturers, each with their own little version of this unit. I believe that the original manufacturer of the Vici 60B is a company called Victor Instruments. They make a few derivatives of the Vici 60. They make the B version, as you see here. They make the D version, which is 1000 volt and 2500 volt. And they make the E version, which is 2500 volt and 5000 volt. And they make the H version, which is a 100 volt to 1000 volt unit. These units, they vary tremendously in price. The Vici is usually one of the cheaper ones. That's around £40. The WinsPEAK is usually somewhere around about £50. So I got the Vici unit originally. I had issues with that, as you'll see. We'll do some of the testing later on in the video. So I got a WinsPEAK unit to see if I was just unlucky with the Vici unit or if it was inherent to the design of it. With regards to what you get with the kits, they both come in cardboard boxes. There is no case supplied with any of these. The only difference is that the Vici unit does have this clip-on cover, so you can clip that over the front face of the instrument and protect it in that manner. And then when you're not using it, you can flip it over and put it on the back, ready for the instrument to be used. You get a little instruction manual with each of the units. The Vici unit also comes with a little neck strap. I'll go through the slots here in this unit. No neck strap with the WinsPEAK unit. Leads wise, they look as though they're actually identical leads, sets of leads that come with this. There's no GS38 cap on these, but you do get the croc clips. They're just the slip-on variety. You can line them up and then clip on. But yeah, pretty not the nicest of quality. Exactly the same with the WinsPEAK unit here as well. The leads, actually, I've just noticed they do actually have the same markings on them as well. So yeah, I think they're just generic leads. So with regard to functionality, the WinsPEAK unit there is the closest to the Victor Instruments unit in both the selection buttons and the operation of the unit. The Vici unit here, this has a rotary switch as opposed to the selection buttons, and it has a separate light and hold unit. There's no data hold unit on the WinsPEAK unit. This unit also has DC and AC voltage measurement, whereas the WinsPEAK and the Victor Instruments only has AC voltage measurement. You also have an ohms and continuity, 2 mega ohms and continuity range function on the Vici 60B as well. Both instruments have 4 input jacks here. They both, for insulation testing, it's the E and the L connections on both of them. You also have a guard terminal here, which is interesting. It's not usual to have a guard terminal on a low voltage insulation tester, so we'll test that out later. And then you have to change position for the volts and ohms reading, or just the AC volts on that unit there. So you can see here with both the units switched on to the 250 volt test function. The Vici unit here, you can press the button in to bring the light on, and that stays. It's a push to hold button, so it stays until you press it again to take the light back off. On the WinsPEAK unit, the light comes on automatically when you press the test button in. They're not bad backlights. There's more fade on the WinsPEAK unit, I guess, as you get over towards the right hand side, but they're perfectly adequate. They light up the screen all okay. With regard to the 250 volt test function. This is where there's another difference between the two units. All three ranges will go up to 2 giga ohms. The 250, 500 and 1000 volt will go up to 2 giga ohms on the WinsPEAK unit. On the Vici unit, it's only the 1000 volt test function that will go up to 2 giga ohms. You can see here only 200 mega ohms on the 500 volt and the 250 volt function. Range selection on this is fully automatic. Range selection on the WinsPEAK is via this button here. Take it down to the lower range, or press it, take it up to the higher range. Both insulation testers have twist to lock functions, so when you're testing you can push it on and twist it to lock it in. This has a permanent alarm that you can hear going off when you put it into test. And this one here, as you saw earlier, this doesn't have an alarm at all, but again you can twist and lock. And both of them have a little LED to allow to say that the test voltage is on, and the little test symbol comes up on the side of the screen there as well. So accuracy for both of these units. This has pretty poor accuracy. I'll put the graphic for this. You can see it goes up to 400% out on the very low resistance readings down at like 100k and that kind of range down there. As a consequence, it just blows the graph clean out. So what I've done in this next graph is remove the actual values that are above 20% tolerance, and it gives you a slightly better impression of the accuracy of the instrument. Insulation testers aren't the most accurate anyway. It goes up to about 18% average accuracy against the WinsPEAK unit that's much more stable. That's got 1.56% accuracy. That's over 77 tests because of the extended range at the lower test voltages on WinsPEAK. So we have 59 tests on the Vici unit there. If I compare it to the other instruments that I've tested, you see on this graph here, something like the Mega MIT40 over 195 tests, that's 0.04% accuracy on that. The MTR 105 kind of splits these two units up at 2.29% over its full range, but obviously it's got a much greater range than these two instruments have. So if you repeat those tests on the MTR 105, more in line with the capability of these two instruments, the MTR 105 is a 0.45% accuracy. Okay, we've set up for AC voltage measurement. We put in 749.8 volts into both the units there. That's the maximum that both of these can handle. And you can see the WinsPEAK unit is 750 volts smack on, and the Vici unit is bouncing around a little bit. 743, 42, up to 746. So yeah, not as stable as the WinsPEAK unit there. So quick test of the ohms and continuity function on the Vici unit. The WinsPEAK unit doesn't have this, so the Vici is on its own. You can see we're on, it's a 2 kilo ohm scale on this, and we're on 100 ohms, and we're reading 100 ohms exact. We'll flick around to 500 ohms, 501. Let's go 1500, 1502. Not bad at all. Let's pop him back down. We'll go to, I think it's 50 ohms that the, so around about 50 ohms is where the continuity buzzer should come on. You see it's coming on 40 there. Goes off at, it's saying 45, this is saying 44 ohms on the resistance box. So that functionality works all okay. I guess the only other thing is just to make you aware the connection is slightly strange for both of these units. Just unplug him and put him out of the way. For voltage measurement and resistance measurement on Vici as well, you use the AC, V and G input jacks on the instrument, which is not quite how you'd expect it to be on a more standard insulation tester. Again, we'll just pull those leads out of there. Hold the Vici unit up there. Hopefully you can see volts and ohms there, and G is the earth connection for the volts and the ohms measurement, the L and the E on both instruments is purely for insulation testing. Okay, so that's that done. We'll set up and we'll do a test with the guard terminal and see how we get on with that. Okay, so we'll give the guard terminal a test. This has to be done each unit individually, and it'll be done at 1000 volts. You can see I've got one lead connected to the top of the bushing, the lead connected to the earth plate, and then the guard terminal is currently floating and not touching anything. So we should be looking at around about 830 mega ohms when we test this, and we've got 838, 839. So that seems good. Just knock him off. We'll connect onto the guard terminal. Now the test should go up to a gigaohm. And there we have it. 1001, 1002. So that unit is completely okay, working fine. Give the WinsPEAK unit a go. Try and keep the leads out of the way of the screen. So, power on. This is test without the guard terminal connected on 1000 volts. Press the lock, we should be around about 830-ish mega ohms again. 29, 28. That's pretty good. And then we'll connect up the guard terminal. Test again, and we should be going for the 1 gig ohm. 191. Yeah, that's looking pretty good there. So yeah, guard terminal seems to work perfectly okay on both the instruments. Okay, so I just want to go through one of the issues I've found on this Vici unit. At the moment I have removed the battery pack, and I've put in these two dummy cells and these two adapters here, and I'm feeding the battery pack via this DC power supply over here. It's set to 9 volts to match the 6A batteries that would normally be in here. I've wired the output of the instrument onto a DC voltmeter here so I can measure the output voltage of the insulation test function, which at the moment is on 250 volts. We'll put the light on there, and we'll put test on, and you can see it's 259 volts. And it does creep up. Usually they go to a value and stop and don't carry on creeping up in the manner that this is doing. So that's the first issue there. And it does it on all of these ranges. 500 volts. See, 520, so we're well over the 500 volts. But again, it creeps up, creeps up, creeps up. And I'll switch it to 1000. Now with this 1000 volt, I can only get up to 966 volts, although it is creeping up, 967. That should be, to the IEC standard, it needs to be above 1000 volts. It can never be below the nominal voltage level of the insulation test. And that's further compounded by the choice in batteries. So I do use these rechargeable cells an awful lot. Nominal voltage on these is 1.2 volts, and I've never had a problem with any other insulation tester using those kind of cells. So 6 times 1.2 volts will take you to 7.2 volts, which we can set here on the supply. And if we watch the display, enter, you can see immediately low voltage signal is coming in. And if I go for the test now, I'll do it at 1000 volts. We're now down to 674 volts. And all these ranges drop accordingly. So I should turn the light on, shouldn't I? Now down to 491 volts, 490 volts. It's actually going the other way instead of slowly rising, it's decreasing. Now, and if I 250 volts, isn't it? Sorry. So 250 volts just creeps over, which is not good. As I said, the IC standard requires the voltage to always be above the nominal test value. So to get rid of the low battery symbol on here, we have to go up to 7.9 volts. The battery symbol clears 7.9 volts. That's roughly like 1.33 volts on one of these rechargeable cells, which when they are freshly charged you will just about get out 1.34 volts out of a rechargeable cell like that. So it will work for a little while on a freshly charged set of batteries, but it won't last very long at all before the low battery symbol comes on. And as you just saw, as the battery voltage is decreased, you can see the output voltage of the test function also decreases, which shouldn't happen. I've never noticed that on any of the other insulation testers that I've ever tested. So that is a bit of an issue with this unit, in my opinion. So what we'll just do now is reconfigure this so that I measure the output current. Okay, so I now have a load bank connected into the output of the insulation tester now, and converted this to an ammeter. I'm going to measure the current flow. We are at 250 volts, 250 kilo ohms, so I should now get 1 milliamp on this instrument. When we hit the go button, my battery voltage is back up to 9 volts, and we can see we can only get 0.693 milliamps out of the tester. So that's another failure. It should be 1 milliamp. We'll go 500 volt setting as well. Turn it back on, and again 0.7 milliamps. So again, not 1 milliamp. Also, this should be reading 500 k ohm on 0.5, and you can see the inaccuracy here that you've got. The final one, 1000. On to 1 mega ohm, and again only 0.5 milliamps out. So if you drop our battery voltage down to 7.2 volts, similar to the rechargeable battery level, our battery symbol has come back on again as before. We'll stay at 1000 volts, which was 0.5 milliamps, and we'll go, now we're down to 0.3 milliamps on the 500 volt, 0.4 milliamps, and 250 volts. Only 0.56 milliamps, so dropping a couple of hundred milliamps really when you're doing that test. But again, it should still be reading at least 1 milliamp coming out of the unit, and it can't seem to do that even on full battery voltage. So the Vici insulation tester just cannot perform to the IEC standard or the requirements of it, but the WinsPEAK unit is exactly the same. The voltage output drops with the battery voltage, as does the current, and the current output can't reach the required standards either. I'll put this little table up of the various measurements made from each of the units with both an alkaline battery pack and a fully charged metal halide rechargeable battery pack as well. And you can see, especially with the current output, it falls quite a way below the required 1 milliamp standard. So I thought I'd just do a quick teardown of the units. First one here is the Vici unit. You can see that this battery compartment here, and the screw is non-captivated, and it is in actual fact just threaded into the plastic direct. There's no insert on this one. Slots for 8 battery cells, but it only uses 6 AA batteries. On the inside of that we've got our little connector lead that goes onto the main PCB. So that's quite a nice touch. And here we have an input jack for powering the meter from a DC supply, an external DC supply, and there's it's got a little cover just there to protect that. In contrast, you can see pretty much the same with the WinsPEAK unit. This does have a metal threaded insert, brass insert there for the screw, which is a machine screw. This does take all 8 batteries to power this up. So a complete pack of batteries there required for this one. Same kind of idea with a little jack that goes in onto the PCB, but they've taped this one to the back of the case to give a little bit of support to the solder joints there. And obviously this unit here does have an external rubber boot as well, whereas it's just a plastic case on this Vici unit. So you can see on the Vici unit where we can get there is a fair bit of solder flux residue around on the connections. There's a streak of solder across there, pretty dirty and untidy within the board really. There's the high voltage transformer there. Just flip him off. Interestingly enough, let's put it that way for you. This is claiming Cat2 600 volts input protection. And if you look here, these are 2 input jacks for the voltage coming in, and I can't see any protection whatsoever. No varistors or PTCs, absolutely nothing. So don't know about that. I'm not convinced that there's much input protection on this at all. We do have a rotary switch here. Looks like the detent is mechanical within the casing over there, and then we've got 3 push buttons there to be enclosed push buttons as opposed to the PCB track variety. What it says, it could be there's a couple there. What are they called? So there might be a bit of input protection there. They look like varistors to me, so could well have a bit of input protection. I'll take that back. But whether that's sufficient to meet Cat2 600 volts, I do not know. In contrast, this is the WinsPEAK unit. Probably a little bit better laid out, componentry wise. Again, there's your selection switches up there, and the other function switches there. They're totally enclosed switches, transformers, everything's all on this front side component wise. Could be a little bit of protection down here for input protection. Can't see much of a clamping circuit though. Yeah, again on the other side, a fair bit of solder flux residue. Not very pretty at all really. This one was claiming. This is claiming Cat4 600 volts. Now that I seriously do doubt. Could be wrong. There's not much in there that convinced me that this is a Cat4 instrument with input protection. Yeah, okay. So there you have it. I'd say this WinsPEAK unit is perhaps a little bit better build, mechanical wise, construction wise, than the Vici unit. It does cost usually a little bit more, so I guess that kind of explains that. But yeah, that's just a little quick look inside to see what we could see. Okay, so there you have it. A quick look at a couple of cheap insulation testers. Both VC 60B plus units there, one from Vici, one from WinsPEAK. Would I use one of these? Professionally, I'd have to say no. For me, the output of the insulation test function doesn't meet the requirements of the IEC 61557-2 standard. Even if I tried to send this unit away for a calibration, it would probably come back as being failed. Outside of that, if you just want an insulation tester to play around with, then they do offer that opportunity. If you're testing something that is perfectly okay, it will tell you that. If you're testing something that has failed insulation wise, it will tell you that as well. The problem will come is where you're testing something that's borderline, and neither of those two units there are capable of putting out the required output under those scenarios. So whereas a tester that could put that output out may lead to failing the device that you're testing, these testers might well actually pass it because it can't put out the right voltage and current on those borderline cases. So yeah, just a play around meter for me as far as I'm concerned. But interestingly enough, it's made me look at another aspect of insulation testers, and with regard to the actual output under different levels of battery charge. So that's something that I'll take away and go and look at some of the other units that I've still got and see if the output of those varies with different battery pack voltages. So that's it for this video. Thanks for watching. Hope you found it useful, and I'll see you again in the next video.